Hello, so in this video I'm going to show you how to solve problem 3, the last part, the 15-point part, part C on exam 2 for physics 12 through 12. This is for the test wrapper. So in this problem you're supposed to solve and find the potential difference VC minus VB. As we know, potential difference is defined as the final potential minus the initial potential, and there's a formula, negative, so the potential difference between the initial and the final is equal to the negative the integral from the initial to the final position. So in this case from point B to point C. Note these are points, not positions yet. And this is actually a path integral, but we're just going to write it as so magnitude of E. Well, we can just write E, vector E, at a specific radius, dot the L along that path. And we were given in the problem that ER, sorry for this writing, is equal to 1 over 4 pi epsilon naught times Q R, the radius from the center, over R2 cubed R hat. So if we plug this in, we can get, let me use this, we can get that VC minus VB is equal to the integral. So now we're going to actually use it in terms of radius. So we know that that point B lies at radius 2, R2 here, you can read that, and point C, which is in the center, is 0 meters from the center. So the R is 0, and we're going to plug in our E. So we have 1 over 4 pi epsilon naught. Write that a little bit better. Times, again from here, Q R from above, Q R over R2 cubed, and our differential is dr. So we know that pi obviously is a constant, epsilon naught is a constant, Q is a constant, R2 is a constant, and the only thing that's not constant is R. And so we can pull everything that's constant out of the integral and get we can get Q, and remember our negative, I almost forgot the negative, so remember we have negative Q over 4 pi epsilon naught R2 cubed. Those are all the constants we can pull out of the integral, and then we're left with integral of R dr from R2 to 0, and just when I have to write it again, I'm going to go ahead and put this integral in brackets and show you that this integral is equal to, so when you integrate, you would get, I believe, 1/2 R squared evaluated from 0, from R2 to 0. When you evaluate that, you would end up with negative 1/2 R2 squared. So we can multiply this by this, and we end up with the following answer for the problem of VC minus VB equals 1/2 times 1/4 equals 1/8 times, let's see, and our negatives have canceled out. So that's a 1/8 right there. 1/8 negatives cancel out. R2 squared, R2, so 1 equals 1/8 times 1 over R2 times 1 over pi epsilon naught and times q we have in the numerator. So I can just simplify that and write this all as VC minus VB equals Q over 8 pi epsilon naught R2. And that is, oops, and that VC minus VB equals Q over 8 pi epsilon naught R2 is your answer. And that's it. I hope this was helpful to me, since the video was for me. So yes, thank you very much.